Easy, James here. Now in this video I'm going to show you how to modify the strobe light on a Technics SL MK2 turntable, so it will go from looking like this to this. Now it's a pretty cool mod. You don't have to go for green, I did, but you can go for yellow, blue, purple, white even. It's not a particularly difficult mod to do, but you will need some basic soldering skills. You need to be a little bit clued up about how LEDs work, and also have a basic understanding of the electronics in the turntable. Now if you're sitting there thinking, oh, I don't know any of those, don't panic, it's all covered in the video. I'll go over everything. So it's going to be quite an in-depth video, but I'd rather give you all of the information that you need rather than you going at it half-cocked and thinking, well, actually I don't really know what I'm doing, or you've got questions. I'd rather get all the information you need to start with. Now this was quite a popularly requested video. Popularly, is that a real word? Yeah, I don't know, we'll go with it. So a lot of you are probably going to be quite excited about it, but also it will help some of the guys who are troubleshooting, because maybe your strobe light has literally just stopped working and you need a little bit of information to get that working again. Or maybe you were one of the guys that emailed me before and said they'd tried doing this mod and actually something went pop and they've shorted something out and now their strobe light doesn't work. So you can use this video to hopefully help you troubleshoot. So without further ado, let's get on. Now first of all I'm going to explain a little bit about how LEDs work, so we'll go over to the whiteboard. Right, now I know some of you already know this, but this is for the benefit of the people that don't, so bear with me on this one. Now LED stands for light emitting diode, and it is essentially just that. It's just a diode that when you pass current through it, it emits light. Now if you look at the symbol for an LED, it is essentially exactly the same symbol as a regular diode, except it's got these two little arrows on here, obviously indicating the emitted light off the diode. Now, like a regular diode, also it has a thing called an anode and a cathode. Now, in English, basically, that means positive and negative. Okay, so you can only pass current one way through an LED, the same as you can only pass current one way through a diode. Now, the other thing is with LEDs is they also have what's called a VF, or a forward voltage drop, like a regular LED. That does vary depending on the colour of the LED. I'll go over that in more detail in a minute. But the only one other thing with LED is they cannot self-regulate the current you put through them. So if you put a voltage across this LED, more than likely you'll just blow the LED up, because it cannot just reject what current it doesn't use. All of it will pass through once you go past its forward voltage drop, and it will dissipate too much heat and instantly it will just probably go pop if the voltage is high enough. So what you need to do is you need to add a resistor in line with the LED to complete your circuit, and that resistor will limit the current going through your LED and prevent you from burning it out. Right, so I've got some LEDs here, and we'll go for red, I think. Yeah, I like red. Red's a nice colour. Now, with LEDs, remember me saying that you have to connect them the right way round. Now on this LED, or on any LED, the longer of the two pins is the positive connection, so that's the anode. The shorter one is the negative, and that's the cathode. So what you need to do is you need to bear that in mind so you can connect the LEDs up the right way round. Now the voltage drop for a red LED is 1.8 to 2.2 volts. So we'll just call that 2 volts. Okay, so let's set 2 volts on the power supply here. So we've got 2 volts, we'll store that. And as for the current that you can flow through this, typically 20 milliamps, a maximum of 30. So we'll call that 25, okay? So let's just set 25 milliamps on here. So 25, set that. And now we'll connect up our LED, making sure you connect them up the right way round. Turn on the output. And as you can see, there's our LED lit up. Quite bright, and that's running happily like that. Okay, that's fine. Now if we take a green LED and connect this up the right way round, we turn our output on. It doesn't work. Now, okay, the reason why it doesn't work, because I know the LED works and I have connected it the right way round. The reason why is because the voltage drop for a green LED is slightly higher. It's actually 3.2 to 3.8 volts. So if we consider that to be basically 3.5, turn it on, there you go, and now the LED works. So different LED colours have slightly different voltage drops, so you have to bear that in mind. Now if you need the information about the LED that you're using, then the company that provides the LED should have all the information that you need. Now if you look either in their catalogue or on the website, it should show you all the information you need in regards to the voltage and the current of the LED. Now if you want to run more than one LED at a time, so let's say 4 for example, you need to connect them in series. Okay, so we've got 4 LEDs here, all connected in series. We have our 3.5 volts for a blue LED set. Connect these up, we have our current set to 25 milliamps as normal. If we turn on our power, as you can see, they also don't light up. Now, I know my LEDs are fine yet again, and I know they're connected properly. The problem here is, again, not enough voltage. So if each LED has, let's say, 3.5 volts across it, then you need to multiply that by the amount of LEDs you've got in series. So 3.5 times 4 is 14. So what we need to do is set our voltage to about 14 volts. Set that. Now our current stays at 25 milliamps because each LED can only handle a maximum of 30 milliamps, so you don't want to exceed that regardless of whether they're in series or a single LED. So we've got our voltage set now to 14 volts. If we turn our output on, the LEDs come on, quite bright as well. That's actually quite dazzling and hurting my eyes, but as you can see, they're running quite happily at 25 milliamps. And if you wanted to run 10 LEDs in series, then you'd need to run at 35 volts if you wanted 3.5 volts across each LED. Again, the current stays at 25 milliamps. Turn that on, and as you can see, they're running quite happily, and that's actually really bright and hurting my eyes, so I'm going to have to turn that off. Right, so let's say you've chosen a colour that you want for your LEDs in your strobe, and let's say for argument's sake you've gone for blue. A lot of people like putting blue on their turntables these days. I personally don't. I think it makes them look cheap and tacky, but each to their own. So let's fire these up. Now these are now running at full current, so they're running at the full 30 milliamps, but obviously they're not because our voltage is slightly lower, so we're at about 27. So you really would not want to run these things at full current when they're actually in the strobe column. There's a lot of ambient light in this room right now, so if we turn that off, you can actually start to see how really bright these things are. So you imagine that that's how far away it's going to be from your platter. That's going to be far too bright, so you do not want to go running these things at that kind of current. Now these things aren't supposed to be bright, it's supposed to just be bright enough to project the light onto the platter. If you have it too bright, it's just going to wash your platter out and make it look horrible. So ideally you'd probably want to run these things more about, you know, sort of 5 to 10 milliamps. I know it doesn't look very bright, but trust me, that is far bright enough when you consider that that's how far away it's going to be to your platter, and bearing in mind that's competing with ambient light. So again, we're actually at 3 milliamps here because we're running at a slightly lower voltage, but we can consider say 10 milliamps, 5, 6, yeah, so somewhere around that. Right, now I've covered LEDs, we need to go into the electronics in the turntable now. Right, I've got the service manual here, and in the service manual they actually provide a full schematic of the electronics inside the turntable, and this is the bit that we're interested in here. Now I'm actually going to draw this on the whiteboard blown up so you can see the details. Right, now this is the part of the circuit that we're concerned with. Now we've got our plus 20 volt supply from the deck, goes through a 150 ohm resistor, goes through all of our LEDs in series, through the transistor and down to ground to complete the circuit. Now this transistor is not on, so the circuit is not completed unless there's a voltage on the base of this transistor. That's this pin here. Now this here is our main control chip. This is the AN6680, and pin 11 of that chip is connected to the base of this transistor. There's a small capacitor here as well going down to ground for a bit of stability, but we don't really have to worry too much about that, but it will affect our waveform. Now pin 11 outputs a square wave which looks like this. So only when the voltage is at this point does the base of that transistor actually turn on, so the current flows through the LEDs. When the voltage drops down to 0 like this, the transistor switches off and the LEDs actually don't light up. Now this happens very rapidly, it's about 100 Hertz, so your eyes won't see that happening. But every time that transistor turns on, the LEDs come on. Every time it turns off, the LEDs go off. So it strobes, hence strobe. Now, the waveform coming out of this pin is going to realistically look a little bit more like this. There is also going to be a slight bit of offset on there as well. Now, although the LEDs are connected to the 20 volt supply, we're not actually going to be putting 20 volts through these LEDs because of that square wave. Because it's not on all the time and it's off some of the time, the voltage that goes through these LEDs is going to be slightly less. Right, so if I test pin 11 on this IC, and as you can see, we get a waveform that resembles what I was talking about a minute ago. Now if I just turn the time base down to 2 milliseconds per division. Right, now if I take a snapshot of that, and we can go ahead and align that with the cursor. Now we've only got 0.6 volts here, but that's because we're testing from the pin of the actual chip. If we want to get the voltage that's across those LEDs, then we want to measure actually across all of the LEDs themselves. As you can see, we're at 500 millivolts per division, and we've actually got 500 millivolts of offset here, so we'll have to take that into account. And also we're aligned with the cursor, we're at 2 milliseconds per division. So if we count the divisions here, that's 2, 4, 6, 8, 10. So between the beginning of this cycle and the beginning of the next cycle, we have 10 milliseconds. So if I look in the service manual for the AN6680 and we look up pin 11, we can see here it says we should have 10 milliseconds cycle time between each cycle of the waveform, and also it shows us what the waveform should be, and that directly corresponds to what we've actually measured. Right, now we're measuring across the actual LEDs, so our oscilloscope is measuring at this point and this point, and as you can see our waveform is very much the same. Now if we go into the frequency counter, you can see we're actually at 101.1 Hertz, and if we go into the duty cycle, we can see the duty cycle of that waveform is 24.5%. Now you can actually try and calculate the voltage from that. So if you go into this mode, it tells us the voltage here anyway, 6.4 volts. Now we've got a slight problem because our LEDs have a voltage drop of 3.2 volts. So 4 times that is obviously greater than 6.4 volts. But the important bit is the current, because we're adding another resistor in line with our LEDs to drop the current down slightly. So with that in mind, we're going to raise the voltage slightly anyway because we're going to be drawing less current through that resistor. So we should be okay with this value. It's mainly the current that we're trying to drop here. Now for calculating the resistor value that you need, you can come over to this website. I'll put a link in the description. It's basically an LED resistor calculator. So you type in all your parameters like the supply voltage, all the LED parameters, and you press calculate and it will give you a resistor value. But the problem with this is because we haven't got fixed parameters in our turntable, and also we've got a little bit of leeway with the resistor value because we're already current limited, I'm just going to calculate it for you because there's too many variables. So if you have LEDs with a voltage drop of between 1.8 and 2.8 volts, so that's like red, yellow, then you're going to need a 560 ohm resistor. Now, if you've got LEDs with a voltage drop of between 2.8 and 3.8 volts, so that's blue, green, purple, white, you're going to need a 470 ohm resistor. Now, in terms of where you can get your LEDs and resistors from, in the UK you can go over to maplins, but they are a bit pricey though, £1.44 per LED. Now, they're good quality LEDs and all, but are they worth £1.44? Definitely not. Now, if you're in the US, you can go over to Radioshack, and they do a pack of 2, but again, a bit pricey, $2.49. But for one-off quantities, if you've got no other choice, that's not too bad. But what I suggest is if you go over to eBay and check out this company called Bright Components. Now, I can vouch for these because I brought quite a few LEDs from here in the past and they've been really good. And in fact, the LEDs that I actually use in this video are from here. So you basically select the size you want, that's 5mm. Then you select your colour, we'll go for green. Then you select your quantity. Now they only do multiples of 10, so we'll go for 10. and 99p plus 99p shipping. So that's £1.98 for 10 LEDs delivered to your door. Now the delivery time is good as well, it's nice and quick. They also give you all the information about the LEDs, the volt drop, current, etc. down here. Also, this company does resistors as well. They do all the common values that you might need, so it's 560 ohms for example. And again, it's only 99p plus the same shipping, and that's for a pack of 50. So that's good. Also, this company, Bitsbox UK, they also do loads of other components and they ship worldwide. They do every resistor value that you're probably ever going to come across. And the price is good as well. For quantities of 50 plus, you're talking 1 penny each. They also do flat rate shipping as well. Also, you can go to maplins to get your resistors. Now, again, they are quite pricey, but if you only need one or two, then, you know, it's your only option. That's not too bad. So there's some good options for you for getting LEDs and resistors, and also you can get other components from these sites as well. Right, now I'm going to go over the tools that you're going to need. Now the first tool is actually optional, and that is a multimeter. Now don't worry too much if you haven't got one, but I will say they are very, very handy for stuff like this. Now if you haven't got one, I will suggest that you do invest in one, because you don't have to buy a more expensive one like this. You can buy a slightly cheaper one. This one I think cost me about £20 in B&Q, or you can get them even cheaper than that if your budget isn't that high. You can go on Amazon, eBay, places like that, and you can get them for literally a £5, and they will do the job for most DIY tasks that you want to do. So I would recommend you do get one, even if you get a cheap one. They will help you out loads. Right, now I'm going to go over the basic tools that you're going to need, and that is you're going to need a medium-sized Phillips screwdriver. You're going to need a really small Phillips screwdriver and a really small flat-headed screwdriver. If you've got one of those little precision screwdriver sets, they'll do the job as well. You're going to need a pair of tweezers. You're going to need a small pair of wire cutters and a small pair of long-nose pliers. You're going to need a sharp knife and one of these desoldering pumps, or desoldering vacuum, whatever you want to call it. If you haven't got one of these, then you can always buy a small roll of desoldering braid as well, but whichever one you've got. And also you're going to need one of these little clamp stand, freehand clampy, crocodile clippy, whatever you bloody call them, because they've got about 75 different names. You need one of those or something similar if you can get one without the magnifying glass or whatever you've got. And last but not least, you're going to need a soldering iron or a soldering station if you've got one. I'm going to use this temperature controlled soldering station. Now it does look a bit retro and cheap, but it is pretty good and it does do the job. So this is what I'm going to be using. No, do you know what? No, I'm not going to finish this video with that because it looks retro. Do you know what? I'm going to go out right now and I'm going to go and buy another one. Bear with me. Right, I'm back now. This is the best one they had. So let's get this out and have a look and see what this is like, shall we? Don't need that. Oh, it's heavy. That's usually a good sign. Right. Okay, well, that's slightly less retro looking. Oh, that can come off for a start. Oh, I hate bits like that. I have to peel them off. Yep, I think this is the one. Let's plug that in. Ah. Yeah, there you go. One slightly less retro looking soldering station. Right, good. We can carry on now. Now, as for parts, you're going to need 5mm LEDs of whatever colour you've chosen. Now, if you're doing 2 decks, then you're going to need 8 of these. You're going to need 2 resistors of whatever value you need for your colour of LED. You're going to need some solder. Now, the thinnest solder you can get, preferably 0.4mm, 0.6, but whatever the thinnest solder is you can get. And also you're going to need some insulation tape. Right, the first step is to switch off and unplug your turntable from the wall. Okay, you do not want this plugged in at all while you're working in here for obvious reasons. Right, next thing to do is lock your tone arm in place so that doesn't go anywhere. Then you can take off your slip mat and you can actually remove the platter. Now, if you find that your platter gets a little bit stuck, just find something like, I'm going to use the rubber handle of these pliers and just tap the centre a little bit and it should come off. That can be a little bit tight, but if you do that, that should lift straight off. Make sure you put that somewhere safe. Then what you need to do is remove all 5 screws from around this cover plate, and then this should just pop straight off. Right, next thing you need to do is pull off this connector at the front here, which goes off to your button assembly at the front here. So disconnect that and just leave that inside the turntable there. And don't forget to take off your little 78 adapter, because that will go for a Burton when we turn it upside down. Right, next thing to do is get the lid for your turntable, and we need to put this on because we're actually going to turn the deck upside down now. So pop this on. Now if you haven't got the lid for your turntable, you can use the lid off another turntable. They are pretty much a standard size. The idea here is to stop us obviously crushing the tone arm and everything. This is just to keep it all suspended off the deck while we flip it over. Right, now what we need to do is obviously to protect this so we don't scratch it up, best thing to do is to put something soft on top of it. Now I'm just going to use my jacket here, but just something on top so that when you flip it upside down you obviously don't go scratching the top cover on your bench. Right, now you've got the deck upside down, you need to unscrew the 4 feet off the bottom. So go ahead and unscrew those, and again keep those somewhere safe. They are expensive, believe it or not. Right, so now you've got the feet off, you need to unscrew the 4 screws that are underneath these feet, and they should be long screws like this. And again, keep them somewhere safe. Best advice I can give you is to use a little tray or something to keep all your screws in so that you don't lose them. Right, now once you've done that, you need to go around and remove all the screws from the bottom of the turntable, and believe me, there's a lot of them. So on we go. Right, now you've taken all the screws out the bottom, you need to remove this bottom rubber plate. Now if you just grab one corner and just lift it, it will be a bit tight, especially if it hasn't been off for a while. And once you lift up one corner, just get your fingers and work your way round like this until you've done one side. Okay, don't be afraid, you're not going to break the turntable, but you do have to give it a little bit of force. Just work your way round and eventually it will come off. Now the wires go through the bottom, you need to pull your audio cables through the bottom, and your power cable you're not going to be able to pull through because there's a plug on it. So just best thing to do is leave it on and just rest it up somewhere out the way. Right, now you've got the bottom off the turntable, you now need to remove this assembly here. This is the power switch assembly. Now you only need to take out the black screws, okay, the ones that go into the actual faceplate, and this one here. Right, so once you've removed all these black screws, then you can go ahead and remove the small silver screw which holds in the power switch. Okay, so this is where you need your small Phillips screwdriver, and do keep that safe because it is very small. Right, then you've got this little plastic film which you need to keep safe because that's got to go back on. And then you can actually pull the power switch off, and it is literally just a little micro switch. A good quality one at that, but it is just a micro switch. Then you can go ahead and lift out the power switch assembly, and because you unplugged that connector earlier, you can just pull that straight through like that. And then you need to take this whole piece to another bench or somewhere where you can work on it. Right, so now you've got this out of the turntable, we can work on this a bit easier now. So first thing you need to do is remove the power switch from the top of the column, just literally pull it off, and that comes off. Right, now inside there's the 4 LEDs as you can see, and there's also this thin diffusing film in here. You need to actually remove that. So this is where you need to get your long nose pliers, grab hold of it and just gently remove it like that. And you need to again keep that safe because these things are just impossible to buy on their own, so do not lose them. Right, now we need to remove this whole collar here. Now to get this off, it's a bit fiddly, but inside there you can just see there's a small black clip there, and there's also one on the other side. You can just about see it there. Now what you need to do is where you need your small little flat-headed screwdriver, and you need to get it in there and basically lever that clip forward while keeping pressure up on that collar. Okay, and then once you've done that side, you can do the same the other side. Just lever it forward slightly, but be careful not to break them off. And once you've done that, you can go ahead and lift that collar off like that. That will be fiddly, guaranteed. If you've never done this before, it will be hard, but just keep at it and don't force it too hard. Okay, that's the important thing. Make sure you lever the clips forward gently so you don't snap them off. and that gives us access to the LEDs themselves, and as you can see they're soldered onto this little circuit board. Well, now to get this board out we need to lift it upwards, and sometimes they actually put glue on the sides of the board, so what you need to do is just kind of run your screwdriver up the side of the board to kind of break any glue joints that might be there. And on the other side, no, they haven't put any that side, but there is a little bit there, as you can see. Just, it's basically like double-sided tape, so you can just go ahead and just, as long as it's broken, and you can see the board's actually loose now. So now what we need to do is there's a little black plastic clip, again with the screwdriver, just lever it forward very gently, and then you can go ahead and pull the circuit board upwards, and it should pull off like so. Well, this is where you could do with your little clamp holder to hold the circuit board in place. If you haven't got one of these, you can just find a way of keeping your circuit board stable and in place while you work. Well, now to make these a little bit easier to remove, best thing to do is actually melt some fresh solder onto these joints, and basically you will end up overloading the solder joint, but that doesn't matter because all the solder is going to go as soon as you use that desoldering pump. So just go ahead and melt some solder onto each one of these joints. Right, so once you've melted some solder onto each one of those legs, you need to arm your desoldering pump. You just need to reheat the solder and just suck the solder off by pressing the button like that. You may need to do it a couple of times, don't worry if you do, just work your way around till you've got them all off, and then very importantly clean your soldering tip, because that's old solder on there and it's probably lead, so get it off your tip. Now on the old LEDs, each leg had one of these little rubber tubes on it. Now you want to take those off and keep those because you're going to put them on the new LEDs. Okay, so collect them all and make sure you don't drop any of them on the floor because you will never find them, guaranteed. Right, now once you've got all your old LEDs off, do not discard them. Put them in a small bag and keep them, okay, because you never know if you may need to put these back in, and they are very hard to track down, these original LEDs, so do keep hold of them. Right, now we're ready to put the new LEDs back onto that circuit board, but it's ideal to test the LEDs before you put them in. You don't want to go through all the hassle of putting the deck back together and then realise one of them doesn't work. I've seen it so many times before and it's a real headache, so best to check them beforehand. Now the easiest way to test these, if you've got a multimeter that's got a diode test setting on there, you'll see a little symbol of a diode. Just flick it to that setting, and if you touch your probes onto the LED, you'll see it lights up. Now it only lights up dimly, but nonetheless it does light up, and it tells you on the screen there, look, 2.54 volts. So that's the voltage drop across the LED. So now we know that LED's working. You test all of them the same way, and if they all light up, top banana, you're ready to put them back in. Right, now it's time to put your LEDs into the circuit board. Now you need to make sure you put these the correct way round. If you put any of these the wrong way round, then none of them will work, okay? So you need to get that right. Now on the board, they've actually put symbols of diodes where they go. Now if you cast your memory back to the images I drew on the whiteboard earlier, you'll remember that this part here is the anode and this is the cathode. Okay, so the side of the triangle with the line is the cathode. Now if you remember, the shorter of the two legs on the LED is the cathode, the longer leg is the anode. Okay, so that's the way round it goes. So the longer leg goes to the beginning of the triangle, the side without the line on it. Okay, now before you put these in, you need to grab these little rubber tubes that came off the old LEDs, and you need to put that on one of the LED legs. It doesn't matter which one, just make sure it's got it on one of them, because this determines the height of the LED off of the circuit board. So once you've got the LED sitting in like that, just go around and do all of them the same way. Right, now you've got these LEDs sitting in the board, you need to hold them in place so you can solder them, and also they need to be sitting inwards at a slight angle like this. Now the best thing I found to do is if you get a piece of electrical tape and just stick the electrical tape onto the ends of the LEDs like so, and then flip it upside down, holding the LEDs with your finger, and then just pinch the tape down to the edge of the board like so. Okay, and that just holds the LEDs in place, so when you tip it upside down, as you can see, they don't fall out, and also it keeps them in at that slight angle while you solder them. Right, now that tape isn't going to hold forever. As soon as you start soldering, the heat's going to make that come off. So you get another little piece of tape like this and just rest it along the top of the board so it doesn't touch where you're going to be soldering, but it's just on the edge of the board there, and then just squeeze that to the tape on the other side and that will hold it in place. And you can do the same on this side as well. And now you've got them held in place, you can start soldering. Right, now I've soldered one leg just to show you what the solder joint should look like. Now the number one mistake that so many people make when they're soldering PCBs is that they put too much solder on the joint. You do not need a lot on there at all. This is why I said use a thinner gauge solder. 0.6 if you can, 0.4, but 0.6 will be good enough. And another thing, you need to make sure you've got a really clean soldering iron tip. If you've got crap on the end there, and even that's starting to oxidize slightly, you need to clean your tip off, because otherwise you're just going to contaminate the joint and make it really hard to solder. Right, this is going to be quite difficult because I've actually got a camera between my eyes and the work. So I'm actually relying on the screen on the camera to do this, so it's not going to be easy. But what you've got to do is you've got to put your soldering iron tip onto one side of the joint and then apply your solder to the opposite side of the joint and just let the solder flow onto the board. And you only need a tiny amount of solder, and that is what it should look like. It should be ramped down to the board. It shouldn't be rounded or bubbled or anything like that. It should be like that. Even that is probably slightly too much because on the screen it's quite hard to see, but I'll do another one. And like I say, you don't need a lot of solder at all. So many people put too much like that. So again, you need literally the smallest amount of solder you can put on there, really. And don't hold the soldering iron on the pad too long either. You know, 3-4 seconds is all you need. If you hold it on there too long, you run the risk of actually overheating the pads, and then basically you're a bit up shit creek. Right, now that is what your solder joint should look like. Okay, there's not too much solder on the pads. They're nice and clean and shiny. If they look kind of like pitted or mottily, then you've got a cold joint or a dry joint. But basically, if they don't look even remotely like that, then basically you need to clean your soldering tip and start again. So now we've got the LEDs actually soldered in place, you can now remove the tape that was holding them in place. And if you look at the LEDs, they should be facing in at a slight angle like this. Right, now you've got your LEDs soldered in place, you can go ahead and trim off the leads now. So just get your cutters and just rest it on the top of the solder joint and just go along and snip them off one by one. Don't try and do them all in one go because you will break the solder joint probably. So one at a time. Right, now you need to put the circuit board back onto the power switch assembly. Now the way it goes on is just the reverse of how it came off, so make sure your wires are sitting in these two grooves in the bottom of the circuit board. Then basically you slide the circuit board down onto that clip, and then you should hear a little click like that, and that's now locked in place, just like that. Right, now you've got the board in place. On the back of the assembly here, there's a little groove just behind the board, so you just sit the wires into that groove, and then you just want to weave the wires around these three studs here, like so, and then push them down into there. Now if you want to, you can put a little dab of hot glue in there, or even just a tiny dab of super glue to hold them in place. I'm not going to bother, it doesn't really matter, as long as they're between that and it's not going to be pulled on and pulled the wires out the back of the board, you should be okay. So now you've done that, it's now time to put the collar back on to the power switch assembly, and the way that goes on is making sure that the window is at the front of your LEDs. Just push down and you should hear a little click when it locates. Okay, like so, and that's now in place. Right, now you need to put the little diffusing plastic back in front of those LEDs. Now if you just bend it round your thumb like that and then just push it in there carefully, it will basically just naturally sit in there like that, and it just sits in front of the LEDs like so. Right, next thing to do is just put your little power switch cover back on. That just pushes on, it only goes on one way. Make sure it works. Yep, perfect. So now you're ready to put this assembly back into the turntable. Right, now you're ready to put the power switch assembly back into the deck, so just feed the wire back inside the turntable and then just drop the assembly back in place, and you can go ahead and sit the power switch back in. Now there's a little stud there that it sits onto, so just push it onto that stud, and then the other hole is for the screw. Don't forget to put your little plastic cover back on, and then put the screw into there, and then use your little screwdriver to do the screw up. Okay, so once you've got that in, you can go ahead and put your 4 black screws back in. Right, so now you need to sit the bottom plate back onto the turntable, and then go ahead and put all the screws back into the bottom. Now if you can't remember how the screws go back in, then I'll show you on the screen where they actually go. Then you can go ahead and screw the 4 feet back on the bottom, and then you can go ahead and flip the turntable back over onto its feet again. And once you've got the turntable back on its feet again, you can go ahead and plug this connector back in the front here. Okay, now we're nearly done, but there is one last step that we've got to take care of before we can put the deck back together completely, and that is to add our resistor in line with the LEDs. Now the ideal thing to do would be to remove this resistor back here, R212, and replace it with a resistor 150 ohms higher than the value that we've chosen. But there's 2 problems with that. Firstly, you've got to remove the entire circuit board and the bearing assembly to get to it. And secondly, if you're not very confident at doing circuit board soldering, then you're probably not going to enjoy trying to do that. So the ideal solution is to basically take the brown wire at the front here on this connector, actually cut the brown wire and solder our resistor in line with the brown wire. So it's kind of like disarming a bomb. Don't cut the red wire. Okay, so once you've cut the brown wire, you need to now strip a little bit of insulation off the ends. Now, if you've got a pair of wire strippers, you can use those. If you haven't got a pair of wire strippers, then you can use a sharp knife. And basically what you do is you rest the cable onto the edge of the blade, and you just very, very gently roll it with your thumb. Hardly any pressure whatsoever. Then you push down with your thumb, pull away with the knife, and it strips a little bit of insulation off the end. So you want to do that for both ends of the brown wire. Right, now once you've prepared the 2 ends of the wire, you need to now take your resistor and just trim the leads down on the resistor a little bit, because they are a bit long, down to about 20 millimeters or so. Okay, now once you've done that, you need to now take one of the leads of your resistor and basically cross it over one of the ends of the brown cable. Then you need to grab both ends with your finger and just basically twist like this. And what you're doing is you're basically twisting the wire around the leg of the resistor like that. So once you've done that, you can go ahead and solder that side now. And make sure it's on there nice and snug, because you want to make a good mechanical connection before you actually solder that. So you want to get your soldering iron and put the tip underneath where you want to solder, then just touch the solder onto the actual leads of the resistor and just melt a little bit of solder on there, not too much. That's more than enough, and that's it. Right, once you've done that side and you've let it cool down, you need to then do the other side, and same story, basically just cross the leads over, and then with your finger and thumb twist them both in opposite directions to form a twist around the resistor leg, just like that. And then you can go ahead and solder that one up. Right, same story, just put your soldering tip underneath, and then you want to touch the solder onto the actual joint itself, not the soldering tip. Just like that. Pull it away and you're done. Right, now we can't just put this back in the turntable the way it is. We're going to have to cover these joints up so they don't short out on anything. So what we're going to do is just take a little piece of insulation tape. You only literally need a tiny bit like that, and then just very neatly wrap this around where you've soldered your joint, like so. Just a few turns, that's all you need, just like that. And then do the same on the other side, like that. So it's nice and neat. You don't need to wrap about 4 miles of tape around it, just enough to cover the joints. And then we can go ahead and just put this back in the turntable, like so. There you go, barely even know you did it. Right, okay, so now you can go ahead and put your plastic cover back on, and then you can go around and replace all 5 screws around the edge of this plastic case. Then you can pop your platter back on, and your slip mat, and now you can plug it in and try it. Right, now I've got about a kilowatts worth of light on at the moment, so if I switch those off, right, now it's still quite bright in here because I've got two 36-watt strip lights above my head, but even at this kind of ambient light level you can see they still light up quite bright. And these LEDs are only running at about 4 or 5 milliamps, so as you can see they're still a bit brighter than the originals, but they're not too bright. And if we turn the light off altogether, as you can see they look pretty funky. I like that. Unfortunately the white balance on the camera doesn't like it, but I do. So there you go. Now I appreciate this has been a long old video, but I'd rather give you the full story, and at least you can't say I didn't include enough information in the video. Now I hope this has been a help. If you have got any comments or questions, bung them in the comments section below. I will put any relevant links and information in the video description below the video. So there you go. Thanks for watching. Nice one.